everyone, this is Professor Gant. I am making this video for the pre-cal class so that we can go over sections 2.3 and 2.7 in the midst of us having to miss class the other day. So anyway, there's a host of problems I want to go through this particular section here. Most of this stuff we've sort of already kind of seen a little bit, but we're just pertaining the whole thing of factoring quadratic expressions to now solving quadratic equations. And so I want to go through a few of these problems to kind of see and give you an idea of what is going on with them and how to solve them correctly. All right, so we'll start with the first problem here. It says find the zeros of the following quadratic function by factoring, and then what are the x-intercepts. So if we start out here, we know that since we have a quadratic function, that whenever we want to find out the zeros of it, we need to take our function and actually set it equal to 0. So we're basically saying f of x is going to equal to 0. And so this also means that we're basically trying to find where the x-intercepts are for this function. So points where the y-coordinate are 0. And since we have a quadratic function that sort of looks like a parabola, we are guessing that we're going to have at most 2 solutions. So if we come and set our function here equal to 0, then we know that we can factor out the greatest common factor for both of them. And then from there, we know that using the zero product property, that we can say that either x is equal to 0 or that x minus 4 is equal to 0. And so, of course, x equals 0 is one of our answers. The other answer, we would add 4 to both sides. And we would see that x equals 4 is our other answer. So what this means is our function has an x-intercept at 0, 0, and at 4, 0. And if we were graphing that, it would look something like this. So that would be at x equals 0, that would be at x equals 4. We could do this, and parabola will look something like that. Okay? So in answering this particular question, we would just type in 0 and then 4. And then again, since they don't ask us to put it in in the form of a point where we have an xy coordinate, we just type 0, 4 again. Okay. So in other words, they don't want us to put it as an ordered pair. That's what I'm really trying to say. All right. So this concludes the first problem, and we'll go ahead and move on to the next problem. All right, so for the next problem, similar thing, we have a function that we need to find the zeros of, and now our function is g of x is equal to 9x squared plus 16 minus 24x. And so now what's different here is that, of course, number one, our function is written in such a way to where we have to sort of rearrange it to make it look the way that we need it to. So here, if you notice, we have 9x squared plus 16 minus 24x. We need to use the commutative property for addition and switch this around. So we would just say 9x squared minus 24x is, plus 16 is equal to 0. Okay? And so from there, if you were going to factor this, the first thing we notice here is that we would try to do a greatest common factor if we could, but we see that that's not going to work. So we could go ahead and try to do factoring by trial and error or by factor by grouping. And so what I'm going to do is do it by trial and error. Since I know I have a sign here of minus plus, then I know that that's going to be minus and that's going to be minus. And here I think if I'm looking at this, 9x squared could factor into 3x times 3x. And then I know for here, I know that if I use 4 and 4 here, then if I check the two middle terms, I know that they will multiply and then add out to a minus 24x, which is exactly what we need. So this actually works. So we know that this will basically simplify to 3 minus 4x quantity squared, which means that 3 minus 4 is going to equal to 0. And we know that by taking the principal root of this. So, and we'll see some examples later on that kind of warrant more notation here. But once that's gone, we just add 4 to both sides. And then divide by 3. And then x is 4/3. And so what this means is this particular quadratic function only has one x-intercept, and it is at the point 4/3, 0. And so if you were graphing that, it would look something like this. Excuse me. Go ahead and erase that. Come out too good. So here we would have our point here at 4/3, and our parabola would look something like that. So of course, if you come here and type it in, you should just get one answer, 4/3, and then the x-intercept doesn't ask us to put it as an ordered pair, so you can do 4/3 again. All right, so we'll go ahead and go on to the next problem. All right, so the next problem that we're asked to do is to solve for the zeros of a quadratic function by using the square root method. And so I want to briefly go over the square root method first before we actually solve this problem. So here the square root method basically says if we have the difference of a square here and another one here, and we set that equal to 0, then here what this basically means is we can take that and add p to both sides, and then when we take the principal root, that'll be plus or minus square root of p. And so it doesn't matter whether p is a perfect square or not, we can still do this. And so that's basically what this particular problem is alluding to on how we should solve it. So using that particular strategy here, we'll go ahead and clear this out and do the following. Let's see, clear. And so now we know that what we want to go ahead and do is set our x squared minus 75 equal to 0. And then from here, we know that the result of this is just going to be that x is going to be plus or minus square root of 25. We already know that. But I'm just going to go ahead and write the steps. So we add 75 on both sides. And then here we say plus or minus square root of 75. Now, square root of 75 can be reduced. We know that 75 is the same thing as 25 times 3. So this would be the same as square root of 25 times square root of 3. And so square root of 25 is equal to 5. And so what we end up with is x is equal to plus or minus 5 times square root of 3. And so this means that we have 2 x-intercepts, and one would be at 5 times square root of 3, 0, and the other would be at minus 5 times square root of 3, 0. So go ahead and put that in. So that's the first one, and that is the second one. And of course, if we were graphing that, that would kind of look like this. Go through here, like that. And so, how we type it in, we'll say 5, and then use our square root sign, 3. Use your right arrow key to get from under the square root sign, and then we'll do the same thing for the other one. And use right arrow key to get out. So those will be our 2 x values where we have our zeros at. And then of course, same thing for the x-intercepts. It's not asking us to write it as an ordered pair. So we're just going to do exactly the same thing as we did last time. And so I keep on saying it's not asking us to write it as an ordered pair, because if they did, we would need to know that and write it accordingly. All right, so let's move on to the next question. All right, so for the next question, we're asked to do pretty much the same thing. And so here, the only difference is now our function g of x looks like x minus 1 squared minus 16, but we still do the same thing. We set this minus 16 equal to 0, and then we add 16 to both sides, and then from this point we take the principal root of x minus 1 squared, and so that would just leave us with x minus 1 plus or minus square root of 16. And so from here we know that square root of 16 is 4, so we would just have plus or minus 4, and then if we added 1 to both sides, we would see that x ends up being 1 plus or minus 4, which means that x would be, in this case, 1 plus 4 is 5, and the other 1 minus 4 is a negative 3. So here are our two answers. And so thus this means that if we were graphing this, that at negative 3 right here, and that 5 would be the two places on the x-axis where our graph would have x-intercepts. So our function would look like that. So here we'll just go ahead and type in those answers now. So we have negative 3 and 5, and then we'll type in negative 3 and 5 again. All right, we'll just go ahead and go on to the next set of questions.